Okay, so let's look at question one. And question one is saying a certain orthodox uses a wire brush to align a patient's hooked tooth, as in figure P4.38. The tension in the wire is adjusted to have a magnitude of 18.0 newtons. Find the magnitude of the net force exerted by the wire in the crooked tooth. Okay, so this is a very simple question because we can see to say the wire is running in two directions, and it is running in those two directions at an angle. It is in both the x and the y axis. So what are we going to do first? We know to say summation of forces is equal to what? Is equal to mass multiplied by acceleration. But since here there's no acceleration involved, you can just say we're trying to calculate this, the magnitude of the forces, or the summation of forces itself. So if we resolve these forces into our x and y components, we're going to notice to say we have a component. Let me change the color here. We have a component in the x there, and another component also in the x running in the positive direction. Then we have two components also in the y, in the same manner, moving in that direction, and another one also moving in that direction. So what are we going to notice? We're going to notice to say the components in the x are adjacent to the theta. So they're both carrying a cosine. So we have t cos theta, even here, t cos theta. Also we have t sine theta, even here we have t sine theta, like that. So the summation of forces in the x will be equal to what? Will be equal to, this one is running in the positive direction, this one is running in the negative direction. So I'm going to have t cos theta minus t cos theta. One is positive here, whilst the other one is negative there. And the summation of forces in the x is going to be equal to what? It is going to be equal to 0 newtons, because I'm subtracting t cos theta from t cos theta, like that. Then let's go to summation of forces in the y. In the y, or in the y-axis, what do we have? We have two forces that are both running in the negative y direction. So this is going to be equal to what? This is going to be equal to negative t sine theta minus t sine theta, like that. So this is going to be equal to what? This will be equal to negative 2t sine theta, like this. As simple as that. So I'm going to say my negative 2. I'll continue. Say my negative 2 multiplied by t sine theta. Which t are we talking about? Is the tension. They've already given us to say tension is equal to what? Tension is equal to 18 newtons. So 18 sine the value of theta, which is 14 degrees, like that. So let's punch into our calculator. Our 18 sine 14. 18 sine 14 degrees. This is 4.35. And if I multiply that by negative 2, I'm getting a magnitude of a force in the y-axis, which is equal to negative 8.71 newtons. Okay, so this is the force that is acting in the y-axis. Now, why is this force negative? It's because it is pointing in the negative y direction. But if we are trying to find the resultant force of this wire on the tooth, we're going to say it is equal to what? It is equal to, or the magnitude of the force. Since magnitude, we're going to say this guy, we're just going to say this will be equal to 8.71 newtons in the y-axis. So, ladies and gentlemen, that is the magnitude of the net force, or the magnitude of the net force exerted by the wire on the crooked tooth. So that is the end of question one. Make sure to subscribe to our channel, register with our tuition center,